Good afternoon. I'm Sanjay Mavi, Senior Lecturer, Department of Mechanical Engineering, IIMT College of Polytechnic, Greater Noida. Today, I'm going to deliver a lecture on tool geometry of single point cutting tools. Before discussing the cutting tool geometry, let us discuss about what is cutting tool and what are their classifications. Basically cutting tool is a wedge-shaped device that removes excess material from a workpiece to get it into desired shape, size, and accuracy. During machining operations or metal cutting operations, this cutting tool forcefully compresses a thin layer of material in the workpiece and gradually shears it off. If we talk about the classification of cutting tools, the most common of classification or the most common basis of classification of cutting tools is the number of main cutting edges that participates in cutting action at a time. On this basis, we broadly classify the cutting tools into two categories. One is single point cutting tool and another is multi-point cutting tool. Now let us discuss these cutting tools, single point cutting tools and multi-point cutting tools one by one. If we talk about single point cutting tool, a single point cutting tool consists of only one main cutting edge that can perform material removal action at a time in a single pass. This is the diagram of single point cutting tool. It shows its various parts and different angles associated with it. Let us discuss these basic elements of cutting tool one by one. The main parts of single point cutting tool are shank, flank, face, heel, nose. In this figure, this is the shank of the single point cutting tool. This is the face. This surface is flank, and this is the heel of the cutting tool, and this is the nose of the cutting tool. Now, what is shank? Shank is the main body of the cutting tool. This shank is used to hold the tool in the tool holder. If we talk about the flank, flank is a surface below and adjacent to the cutting edge. In this figure, we can see here, this is the flank. This flank is below the side cutting edge. And this is also flank. This flank is below the side cutting edge. Face. Face is the surface on which the chips slide. In this figure, we can see here, this is the face. During cutting operation, this cutting edge or side cutting edge cuts the material from the workpiece, and the shear of material which is removed from the surface of the workpiece is slides on this face. Now come to the heel. Basically heel is the intersection of the flank and the base of the tool. It is the intersection of the flank and the base of the cutting tool. We can see it in this figure. This is the heel, and it is the intersection of flank, and base. Base is the opposite surface of this face, so that it is the bottom surface of this cutting tool, and these are the flanks. So this is the intersection of base and the flanks. This is called heel. Now come to the nose. Nose is the point where the side cutting edge and end cutting edge intersect. We can see it in this figure. This is the nose, and it is the basically point of intersection of this side cutting edge and this end cutting edge. This is the nose. So here we can repeat these main parts again. This is the shank, which is used to hold the cutting tool in the tool holder. This is the flank below the cutting edge. This is the face. This is the heel, and this is the nose. Now come to the nomenclature of single point cutting tool. If we talk about the nomenclature of the single point cutting tool, these are the basically different types of angles which are associated with the single point cutting tool. This is the orthographic projection of this cutting tool. This is the pictorial view of single point cutting tool, and on that page, on that slide, this is the orthographic projection of this that cutting tool. This is the front view of that cutting tool. This is the top view, and this is the left hand side view. In this figure, we can see it is the shank, it is the face, nose, this is heel, and these are the some angles which are associated with the single point cutting tool. This is the side cutting edge, and this side cutting edge makes the angle with this side of the cutting tool is called side cutting edge angle. This is the cutting edge, and this edge cutting edge makes that angle. This is called end cutting edge angle. This is the back creek angle. Back creek angles may be positive, negative, and zero. It depends on the material on which cutting tool is to be used. Back creek angle may be, as I have said earlier, may be positive, negative, and zero. If we machine a harder material, then we need a stronger cutting tool. For that, we need positive, more positive back creek angle, and so on. This is the relief angle and clearance angle, and this is the end relief angle. These angles are provided to avoid the friction or contact between workpiece and these flanks. So this end relief angle and clearance angle is very necessary. If we don't provide these angles in this geometry, then the unnecessary friction or contact of the workpiece and cutting tool may take place, and that cause the damage to the workpiece and the cutting tool both. Now come to the advantage of single point cutting tool. What are the advantages of single point cutting tools? If we talk about the advantage of single point cutting tool, the design and fabrication of single point cutting tool is simple and less time consuming, because it has one main cutting edge. So the design and fabrication or manufacturing of the single point cutting tool is quite simpler than in comparison of multi-point cutting tools. and design fabrication is simple, less time consuming. So the tools are single point cutting tools are cheaper in comparison of multi-point cutting tools. If we talk about the disadvantage of single point cutting tool, there are some disadvantages of single point cutting tool. The big disadvantage of single point cutting tool is its life, the tool life. The tool life of single point cutting tool is very low in comparison of multi-point cutting tool. Why? Because the cutting edge of single point cutting tool continuously remains in physical contact with the workpiece during the machining. So the tool wear rate is very high, and that results in low tool life or less tool life. Due to continuous contact, rate of rise in tool temperature takes place, and it is very high generally. And as I have said earlier, it accelerates the tool wear, so results in less tool life. And on the other hand, these high temperatures cause thermal damage to the workpiece and cutting tool both as well. These high temperatures can rise, plastically deform the tool tip, and that can lead to poor accuracy in machining. The temperature of cutting tool tip uh, increase from the marked temperature, it will result negatively, affect the workpiece and cutting tool negatively. Now, let us discuss the tool signature or tool designation. Tool signature or tool designation is a convenient way to describe the tool angles by using the standardized abbreviated system. The main types of tool signature systems are given as ASA. ASA stands for American Standard Association. In this American Standard Association, these are the main elements of the cutting tool which are given here. First is back rake. First one is indicating the back rake angle, then side rake angle, then end rake and relief angle, side relief angle, and cutting edge, side cutting edge, and then at last nose radius. We will discuss this tool designation or tool signature by this example. This is the example of a cutting tool, single point cutting tool, and in this example here we are having this number 8, 8, 5, 5, 6, 6, and 1. And as per this American Standard Association, the angles of tool for this signature or designation are as given in the slide. This 8 is the back rake angle, and back rake angle is 8 degrees. The side rake angle is again 8 degrees, and relief angle is 5 degrees, and side relief angle is again 5 degrees, and cutting edge angle is 6 degrees. Side cutting edge angle is 6 degrees, and nose radius is 1 inch. So by giving this number, we can explain the different angles associated with the cutting tool. Now come to the properties of cutting tool materials. Properties of cutting tool materials means the cutting tool materials of which our cutting tool is made up of. So what should be the properties of that material of which we want to make a cutting tool? And obviously the cutting tool material should be harder than the workpiece on which the cutting will take place by this cutting tool. Means the cutting tool material must be harder than the workpiece material. Second one is the cutting tool material should be tough. The toughness of the cutting tool material should be high. Cutting tool material should be cheap as well. This cutting tool material must be high resistant to wear and tear, because for cutting operations the physical contact between the cutting tool and workpiece takes place. Due to this, the friction takes place between these two, and the wear and tear of the cutting tool may take place or takes place. So the rate of wear and tear of cutting tool material should be low, so that our tool life is longer. The cutting tool material should be easily fabricated. Means the material of which our tool is made up of is easily fabricated or manufactured. These are the some mechanical properties of cutting tool materials. Strength. Strength is very important property of cutting tool material. Ductility, hardness, brittleness, malleability, elasticity, stiffness, flexibility, toughness, creep, resilience, plasticity, fatigue, and machinability. These are the some mechanical properties which are supposed to be a cutting tool material should have. Now come to the cutting tool materials. There are many types of cutting tool materials, of which some important or main cutting tool materials are given as number one is high carbon steel. High carbon steel is used as cutting tool material. Number two is high speed steel. This is also called HSS. Cemented carbide, ceramics, diamonds. Now let us discuss these. High carbon steel. The high carbon steel's structure is granular. It is more tough and elastic than mild steel, as usual. It is generally difficult to weld as it has more carbon content. It can be magnetized permanently, and it has the properties to absorb shocks and vibrations. It is used to make machinery parts and cutting tools. High speed steels, HSS. High speed steel cutting tool materials are generally very frequently used to make cutting tools, because these materials or the cutting tools of these materials may be used for machining at high temperatures, and these are further if we classify these further, these are T type HSS, in which tungsten is the main alloying element. Others are M type. In this HSS, molybdenum is the main alloying element. These high HSS or high speed steels are used for to make cutting tools for drilling machines that are called drills, taps, milling cutters, saw blades, lathe tools, etc. These are the cemented carbide, and the cemented carbide uh, is a material which has high hardness at high temperatures. It is also called good hard hardness. It has very good wear resistance. It is having high thermal conductivity and toughness lower than high speed steel. And other cutting tool material is ceramic. Ceramic is also used for to make cutting tools, and diamond is also a cutting tool material, and it is also used for cutting tool to make cutting tools, but it is very expensive, so we are using it as per the requirement where other cutting tool materials are not applicable. Thank you.